Scale factor as a percent for a scale drawing. Today I will demonstrate my mathematical ability to explain the scale factor as a percent of the original drawing through class discussion. Okay, so the scale drawing is simply it's a representation of an object. I'm going to say an object or a drawing. Because it can be either, it could be a scale model or it could be a scale drawing. And so it really doesn't matter. It's just a representation, whether it's a larger representation or a smaller representation. Okay, so I'm going to skip down here to the scale factor. Scale factor is simply what we're going to increase or decrease the original object by. Okay, it can be a fraction, it can be a ratio, it can be a percent. Okay, it can be any one of those three. Remember, it's a fraction, a ratio, or a percent. All right. Now, and it's simply again what we can increase or decrease the original picture by. All right. Now, once we know what the scale factor is, then we can look at an enlargement. So, an enlargement, if I'm going to look at a percentage, it's more than 100%. So if I say I'm going to increase this picture by 150%, okay, I'm enlarging it. That will be an enlargement because I'm making it bigger by 150%. Okay. Conversely, if I look at a reduction, okay, it's definitely going to be smaller. So it's going to be smaller than 100%. So if I'm going to say my scale factor of this drawing is 65% of the original drawing, that my new drawing, my scale drawing, is going to be smaller by 65%. All right. Now, it works the same with fractions. Okay. In enlargement, I'll have a fraction larger than 1. So like 2 or 3 or 4.5. Or I could have a reduction. It's going to be a fraction less than 1, like 1/2, 1/4, 2/3. Right, those would all be a reduction where I go smaller. All right, let's go ahead and see how this plays out in some of our problems today. All right, so let's look at the scale factor. All right, remember that's what I'm going to increase or decrease an object by. Well, I have this original picture here. All right, I have figure A and figure B. Well, I think we can all agree that figure A is going to be a reduction. All right. It's definitely a reduction. But by how much? Well, when we figure out the scale factor, it is our new over the original. Wow, that really doesn't look all that different than what we've been working on, right? So I could put 1.5 over 3. Now, it does, the kicker here is it has to be a corresponding side. I couldn't go 1.5 over 4 because they're not corresponding sides. All right? So you have to pick the corresponding side. Now, if I want to see are the sides and the top being reduced by the same, I could figure that out as well because I could go 2 over 4. It doesn't matter where I go. All right? What matters is that I pick the corresponding side. So this side corresponds to this side. This side corresponds to this side. All right. If I reduce 1/2 over 3, 1.5 over 3, it reduces to 1/2, or I know that is the same as 50%. Okay. 2/4 also reduces to 1/2, which is also 50%. So figure A is 50% of the original shape. All right. Now let's look at figure B. Well, figure B is definitely larger, but by how much? Well, let's find that out. So it's still, like we talked about up here, it's still new over old, okay, or new over original. So I'm going to pick 4.5 over 6. No, 4.5 over 3. Okay, and 6 over 4. Okay? Well, this reduces down to 3 over 2, which is 150%. This reduces to 3 over 2, which is also 150%. So I would say that figure B is 150% of the original shape. This kind of looks like a snowman. Kind of fitting since we're kind of in the winter time. All right. So figure B is 150% of the original. Figure A is 50% of the original. So here, I'm going to tell you the scale factor is 150%. And I want to know what the new dimensions are. New dimensions. Okay. Well, this is 1. I'm going to start right here. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 units. This is 2 units. This looks like 2, 4. This looks like 4 units. That's what I'm going to say, and this is 1 unit. Okay? Now, I want to know what the new dimensions are. So if I take 2, I can simply multiply it by 1.5. Now, you may ask, why did I get 1.5? Well, I took 150%. Okay, I moved my decimal 2 spots, 1, 2, to make it a decimal. Because if I make it a decimal, then I can multiply. So 2 times 1.5 is 3. Okay, so this new side is going to be 3 if I was to enlarge it. Now, I do the same thing, 12 times 1.5. Okay, 12 times 1.5 is going to be 18. Well, and then 1 times 1.5 is 1.5. 4 times 1.5 would be 6. Okay? So if I was to enlarge this, I would just simply take my scale factor. If it's a percentage, I'm going to make it a decimal, and then multiply that decimal by whatever the dimension is. Okay? I should write this 4 times 1.5 is 6. And so then if I wanted to redraw this, I would get a grid out and I would have you redraw this. All I wanted you to really do on this one is just to use the scale factor. If it's a percentage, it's quite easy to take it to a decimal. All right? Okay, so now it says how to figure both. Well, let's see what it's actually talking about. It says Chris is building a rectangular pen for his dog. The dimensions are 12 units long and 5 units wide. Okay. Chris is building a second pen that is 60% of the length of the original, and so this is going to be 60%, and 125% of the width. This is going to be 125%. Okay? It says write equations to determine the length and width of the second pen. Basically, I want to know what the new length and the new width is. Well, this is pretty similar to what we talked about on the last slide, where I can take 12 times 0.6. How do I get 0.6, you might ask? Well, I take 60%, move my decimal 2 spots. Okay? So when I go 12 times 0.6, I'm going to get 7.2 units. Okay? When we're talking about measurements, we need to give them last names. And I can take 5 times 1.25. Why 1.25, you might ask? Well, I have 125%. I want a decimal, go 1, 2. Okay, 5 times 1.25 is going to be 6.25 units. Okay, so this would be my equation. Okay, and this would be my answer. And that's all. Most of the time, though, they're going to be the same. Now, just kind of to recap what we talked about, the scale factor is simply the number that determines the enlargement or the reduction of the new shape. Okay, if it's greater than 100% or the fraction is greater than 1, it's going to be an enlargement. If it's less than 100% or the fraction is less than 1, it's going to be a reduction. Okay, most of the time you're going to enlarge or decrease by the same scale factor. There's not a lot of times you're going to have two different scale factors like you have here. But if you do, they're going to tell you. Okay, if they just tell you one scale factor, then you're going to do it to every measurement. All right. So this is basically dealing with scale factors. Let's look at the last slide. And the last slide, as always, is your to-do list. You need to make sure you do the quiz on Schoology, write your question and bring it to class, and write your summary on your notes. And guess what? I will see you in class.